Good morning to all. This is Anvesh from AAA branch. So I wanna explain. Today my topic is about the four quadrant operations in electrical drives. So firstly, the four quadrant operations on a DC motor. The four quadrant operations of any drives or DC motor means that the machine operates in four quadrants. They are forward braking, forward motoring, reverse motoring, and reverse braking. A motor operates in two modes: motoring and braking. A motor drive capable of operating in both directions of rotations and of producing both motoring and regeneration is called the four quadrant variable speed drive. So this is a motor drives capable of operating in both directions of rotating and of producing both motoring and regenerating is called a four quadrant variable speed drive. In motoring mode, the machine works as a motor that converts the electrical energy into the mechanical energy supporting its motion. In braking mode, the machine works as a generator and converts mechanical energy into electrical energy, and as a result, it opposes the motion. The motor can work in both forward and reverse directions, that is, in motoring and braking operations. The product of an angular speed and torque is equal to the power developed by a motor. For the multi-quadrant operations of drive, the following conventions about the signs of torque and speed are used. When the motor is rotated in the forward direction, the speed of the motor is considered positive. The drives which operates only in the one direction forward speed will be their normal speed. In loads involving up and down motions, the speed of the motor which causes upwards motion is considered to be in the forward motion. For reversible drives, forward speed is chosen arbitrarily. The rotation in the opposite direction gives reverse speed, which is denoted by the negative sign. So in loads involving up and down motions, for reversible drives forwards, speeds is chosen arbitrarily. The rotation in the opposite direction gives reverse speed. So that was denoted by the negative sign, and forward direction is to be in the positive sign. And the rate of change of speed positively in the forward direction or the torque which provides acceleration is known as a positive motor torque. In the case of retardation, the motor torque is considered negative. Low torque is opposite to the positive motor torque in the direction. The rate of change of speed positively in the forward direction or torque which provides acceleration is known as a positive motor torque. In the case of retardation, the motor torque is considered negative. Load torque is opposite to the positive motor torque in the direction. So this is the four quadrant. Uh, this is four quadrant shown. So in the first quadrant it is a forward motoring, and in the second quadrant it is a forward braking, and in the third quadrant it is a reverse motoring, and in the fourth quadrant it is a reverse braking. So if it is lying in the first quadrant, so that the torque is positive and the speed is also positive. When this is lying in the second quadrant, that means it a forward braking, the torque is negative and the speed is positive. When the slice in the third quadrant, it means the torque is negative and the speed is also a negative. When it is sliced in the fourth quadrant, the torque is positive and the speed is negative, so it is called as reverse braking. So these are the four quadrant in electrical drives, four quadrant operation in the drives. So in the first in the detail, in the first quadrant, power developed is positive and the machine is working as a motor supplying mechanical energy. The first quadrant operation is called as forward motoring, and the second quadrant operation is called as braking. In the first quadrant, in this quadrant, the direction of rotation is positive and the torque is negative, and thus the machine operates as a generator developing a negative torque which opposes the motion. The kinetic energy of rotating parts is available as electrical energy which may supplied back to the mains. In the dynamic braking, the energy is dissipate in the resistance. The third quadrant operation is known as the reverse motoring. The motor works in the reverse direction. Both the speeds and the torque has negative values while the power is positive. In the fourth quadrant, the torque is positive and the speed is negative. The quadrant corresponds to the braking in the reverse motoring mode. So these are the four quadrants and the brief explanation in this. There are two values that are in this four quadrant operation, that is speed and torque. With those two values, they will be varying there will be varying these four quadrants. And the applications of these four quadrant operations are the compressor, a pump, and a fan type load requires operation in the first quadrant only. As their operation is unidirectional, they are called one quadrant drive system. Transportation drive requires operation in the both direction. If regeneration is necessary, application in all four quadrants may be required. If not, then the operation is restricted to the quadrant 1 and 3, and thus the dynamic braking or mechanical braking may be required. In hoist drives, a four quadrant operation is very much needed. So these are the applications of the four quadrant operations in this four quadrant operation. So these four quadrant operation and its relation to the speed and torque and the power output are summarized below in this table. So if you see this, in these functions, the first one is forward motoring. It is the first quadrant, and the speed is positive and torque is positive, and the power output will be also positive. And the second is forward braking, and that is second quadrant. That means the speed is positive and the torque is negative, and the power output will be also be negative. In the reverse motoring, this is the third quadrant. The speed is negative and the torque is negative, but the power output will be the positive. And in the reverse braking, that is the fourth quadrant. The speed is the speed is negative, the torque is positive, and the power output will be negative. So these are the relationship between four quadrant operation. So between the speed and torque and power. And thank you. So this is my topic about the four quadrant operation. The first quadrant is forward motoring, forward braking, forward reverse motoring, and reverse braking. These four quadrant operations are there in the four in this electrical drives. So